Okay, so we're going to work through some trig equations in this video. And these are kind of tough, but a couple of things to remember. First, we're going to tap into a lot of background knowledge that includes what you know about solving equations. It's like to start each one, you can almost think about the trig functions not being there, just think about dx. It's like if you were going to solve this number 1 for x, you would want to get x by itself. Well, the same idea, we're going to work to get this trig function by itself. So let's subtract 1 from both sides and then divide by 2. And so that'd give me 2 sine x is equal to -1, and then sine x is equal to -1/2. And the other thing with these trig equations is they have actually an infinite number of solutions, but the directions will always tell you where to stop. So we're going to stop on this first one at 360. So we're going to solve on the interval from 0 to 360 degrees. So we're only looking for solutions one time around the circle. So from here, I like to call this is the boss. What he says goes. And this equation says sine is a negative number. Okay, so then we think back, well, what do we know about sine being negative? We know sine is negative in quadrants 3 and 4. And so those are the only quadrants you're going to look for solutions in. And I always actually like to kind of make a note of that. So 3 and 4, that's where sine is negative. And then we'll try using our unit circle if we can. In this case we can. We're just looking for where sine is negative. And it's the y value, and it happens right here at 210 degrees. And then it happens again over here in quadrant 4 at 330 degrees. And so those are our two solutions on the interval from 0 to 360. Okay, so on this next one, this one's a little tricky with the setup, but there's multiple trig functions. If that happens, one strategy is to try to factor. And so let's set everything equal to 0, like we would if we were trying to factor like a quadratic equation. And then now I can see the greatest common factor for these two terms is sine. So let's take out a sine theta. And then now, just like if this were a quadratic function, we're going to set both of these pieces equal to 0 and treat them as two separate equations. And so here I have sine theta is equal to 0, and then tangent theta minus 1 is equal to 0. So sine theta is equal to 0. Well, when is sine 0 on the unit circle? So this is not really a positive or negative. We just have to look at the circle and say, where is sine 0? That's where y is 0. And that happens at 0 degrees. And then it also happens again at 180 degrees. And so for this part of the equation, theta is 0 and 180. But we have this other equation we need to solve, and that's tangent theta minus 1 is equal to 0, and we can solve that by getting tangent by itself. Okay, and then once again, we're going to try to use our unit circle. Let's clean that up a little bit. And we're looking for where tangent theta is positive. So he's the boss. This is tangent's positive, and tangent is positive, we know, in quadrants 1 and quadrants 3. So we are looking for answers in quadrants 1 and quadrant 3. Well, if you remember on the unit circle, tangent is y over x. And so when y is the same thing as x, it will be a value of 1. And so that happens at 45 degrees. And then in quadrant 3, it happens again at 225 degrees. So theta from the tangent piece is 45 degrees and 225 degrees. And so this makes the solutions to this original equation here all four of these values. So we have 0 works, 180, 45, I should have put those in order, and then 225 are all solutions to the equation. Okay, on this last one, let's switch this up just a little bit, and let's solve for this in radians. And so here, if your directions say solve on the interval 0 to 2 pi, then that means they want their answer in radians. And so if you have to use your calculator, you would just have to change the mode on your calculator. So this is a quadratic expression with trig functions, and we can factor this. Actually, let's just rewrite it without the trig functions. And think about how you would factor this. You would have 1 times -2, and you're looking for two numbers that multiply to -2 and add to 1. So we could factor that as 2 and -1. And then the difference here is we actually have tangent, so let's put those back in. We're going to say, well, this is actually tangent x minus 1, and then tangent x plus 2. And now we can solve these two equations separately. So tangent x is equal to 1 when we move the 1 over. And we've already actually done that one. And then tangent x is equal to -2. So on this tangent x equals 1, let's just take our answers from above. We already found answers to that to be 45 and 225, but let's use the radian version. So that's pi over 4 and then 5 pi over 4. And then tangent x equals -2 is a little bit trickier because we do not have a -2 on the unit circle. So we're going to have to use our calculator. And that's okay because we have a way to get rid of this function, or we have a way to find angles. Remember, to find an angle, we use the inverse. So in this case, we have tangent inverse of -2 is equal to x. And this is something you would just type in your calculator to find a value. And when we do that, we get the value of x is equal to -1.107. And we'll stop there. Okay, but this is a little bit of a problem because this value is down in quadrant 4, and we want all of our answers in between 0 and 2 pi. And so let's draw this out. We know from our inverse functions that tangent inverse gives me an answer in quadrants 1 or 4. And so this angle here is -1.107. What we want is for tangent to be negative. Tangent is negative in quadrants 2 and quadrants 4. So what we have found is a reference angle, but we have to move that reference angle around. So my reference angle, I can just make it positive, 1.107. And then to find the angle in quadrant 2, I need to do pi minus 1.107. There's pi, and so I get pi minus 1.107. And that gives me 2.034. And then to find an angle in quadrant 4, I have to subtract it from 2 pi. 2 pi would be all the way around, and so we do 2 pi minus 1.107, which gives me an angle of 5.176. So moving these angles it's difficult to do. It's also, we've seen this before in different problems, so try to draw back on what you know with reference angles. And let's go ahead and write the final answers all together here. So the answers for x are pi over 4, 5 pi over 4, 2.034, and 5.176.